In 7th problem, in each of the following cases, state whether the function is bijective or not. Justify your answer. What we have to do is, we have to take this function and we have to show it is bijective or not. In order to show the bijective, what we have to prove? It is 1 to 1 and on to. Similarly, we have to show the second subdivision is bijective or not. Bijective means injection and surjection, which is 1 to 1 and on to. Let us do one by one. So, I am considering the first subdivision, f of x is equals to 2x plus 1. I am considering it as equation 1. As I already told you, to prove it is 1 to 1, we can consider f of x is equals to f of y. From this, if we can show that it implies x equals to y, then we can say that f is a 1 to 1 function or not. Okay. So, f of x means 2x plus 1. F of y, in the sense we have to replace x as y. So, 2y plus 1. Plus 1 on both sides will get cancelled, because if I take it to the other side, it will become obviously minus 1. So, remaining is 2x is equals to 2y, 2 and 2 will get cancelled, x is equals to y. So, we took f of x is equals to f of y, from that we can bring x is equals to y. Therefore, this is 1 to 1. Next, we can show it is onto. If we show it is onto, then we can say that the first option is bijective. Next, to check onto condition, what am I going to do is, I am going to consider f of x is equals to y. If f is a mapping from x to y, then f of x equals to y. It can be written in such a way. F of x is given as 2x plus 1, which is equals to y. From this, I will write the value of x. 2x equals to y plus 1. If it goes to the other side, it will become minus 1. X equals to y minus 1 by 2. This is a onto function. How do I say it is an onto function? Is if I take any value of x, definitely I will get a, if I take any value of y, definitely I will get the value of x. Therefore, this is called as an onto function. Therefore, it is bijective. First option we have shown it is bijective. We will move on to the second option. Second option we will check first it is 1 to 1. If it is 1 to 1, then we will move on to the onto operation. So, we will consider f of x as given is 3 minus 4x squared, which we will consider it as equation 1. Similarly, we will take f of x is equals to f of y. From this, if we can bring x is equals to y, then f is 1 to 1. F of x is given as 3 minus 4x squared. F of y means we have to replace x as y. It will become 3 minus 4y squared. 3 and 3 will directly get cancelled. Minus 4x square equals to minus 4y square. Minus and minus will directly get cancelled. 4 and 4 also will get cancelled. X square equals to y square. Taking square root on both sides, it will give me x equals to plus or minus y. Whereas this is not a 1 to 1 function, because x has two images, plus y and minus y. Therefore, it is not 1 to 1. With this itself we can stop, because if it is not 1 to 1 itself, it may not be bijective. It is not bijective. So, in the 8th problem, it is given as a value as minus 1 comma 1 and b as 0 comma 2. A value represents the values of x and b value represents the value of y. If the function f is a mapping from a to b defined by f of x equals to ax plus b, it is an onto function. We have to check whether it is an onto function, as well as we have to find the values of a and b. We will do it one by one. So, we will start off with the given function f of x is equals to ax plus b. As I told you, this represents the values of x, this represents the value of y. So, y has two values 0 and 2. First, we will consider f of x is equals to 0, which means f of x can be represented instead of y as well. So, we will consider f of x is equals to 0. F of x value, it is given as ax plus b, which is equals to 0. First, we have taken the value of y as 0. Similarly, we will take the value of x as minus 1. So, when x is equals to minus 1, we will substitute here a into minus 1 plus b equals to 0. So, this will become minus a plus b equals to 0. This we will consider it as equation 1. Next, what will we do is, we will consider the value of f of x, that is y as 2 and x as 1. First, instead of f of x, we will replace it as ax plus b equals to 2. We will consider the value of x as 1. So, what will I get? A into 1 plus b equals to 2. Therefore, a plus b equal to 2. This we will consider it as equation 2. Now, we will simplify equation 1 and 2 using linear equations. So, minus a plus b equals to 0, a plus b equals to 2. Equation 1, equation 2 will simplify, plus a minus a will directly get cancelled. 2b equals to 2, b equals to 2 by 2, b equals to 1. Thus, we got the value of b as 1. Next, we will substitute b equals to 1 in either one of the equations. I will substitute b equals to 1 in first equation. First equation is nothing but minus a plus b equals to 0, minus a plus b value is 1 equals to 0, minus a 1, if I take it to the other side it will become minus 1, a equals to 1. So, a value is also 1, b value is also 1. Thus, we have found out the values of a and b. Now, we will find whether it is an onto function or not. So, what we are going to do is, we will substitute the value of x here. We also know the values of a and b, we will substitute here. We will see what the value of y we get. A equals to 1, b equals to 1. So, first f of minus 1, which means a value is 1, x value we are taking it as minus 1, plus b value is also 1. So, minus 1 plus 1, which is equals to 0. So, x value I took as minus 1 and y value I got as 0. Next, what I am going to do is, I am going to take the value of x as 1. I am substituting here, a is 1, x is 1 plus b is also 1. So, 1 plus 1, 2. For 1, we got the mapping as 2. So, we will represent it in an arrow diagram. A is given as minus 1, 1, b is given as 0, 2. When it is minus 1, we got as 0, though minus 1 is mapped to 0. When it is 1, we got 2, 1 is mapped to 2. So, all the elements in B as a pre-image. Therefore, this is an onto function. So, for this problem, we found the values of A and B and we also shown it is an onto function. So, in the ninth problem, function f is defined as f of x is equals to, it is categorized into 3 types and we need to find the values of all these. Let me draw this f of x in a graph. So, let us see how to do. I am considering x axis because only the x values are given 0, 1, 2, 3, 4, 5, 6. So, this side it is minus 1, minus 2, minus 3, minus 4, minus 5, it goes on. Okay, so first value is if x is greater than 1, whereas 1 is not included, it is greater than 1. So, 1 is not included, I am using open brackets. F of x value is x plus 2. Next, when x value varies between minus 1 and plus 1, whereas both minus 1 and 1 is included, therefore, I will use closed brackets. When it is between minus 1 and 1, f of x value is 2. Next, if it is between minus 1 and minus 3, whereas both minus 1 and minus 3 is not included, I am using open brackets. If it is between minus 1 minus 3, f of x value is x minus 1. Let us consider this as interval 1, 2 and 3 and we will find the values of these 4 subdivisions given. First value we are asked to find is f of 3. F of 3 in the sense x value is 3, x value if it is 3 it varies in the, it lies in the third interval. Therefore, we should use the value of f of x as x plus 2. So, we have to substitute x plus 2. We have to substitute x is equals to 3. Therefore, f of 3 equals to 3 plus 2 which is 5. Therefore, f of 3 is 5. Second option is f of 0. Since the value of x is equals to 0, it falls in the second interval. Therefore, we have to use f of x is equals to 2. So, f of 0 if I substitute in place of x, it will also be 2. F of 0 equals to 2. And the third option we have to find is f of minus 1.5. If it is minus 1.5, if it lies in the interval, first interval, therefore, we have to use f of x is equals to x minus 1. So, in place of x we have to substitute minus 1.5. So minus 1.5 minus 1, which will give us minus 2.5. Therefore, f of minus 1.5 equals to minus 2.5. And the fourth subdivision we have to find is f of 2 plus f of minus 2. If it is f of 2, it lies in the third interval. Therefore, we should use the f of x value as x plus 2. Therefore, f of 2 equals to 2 plus 2, which is 4. F of 2 equals to 4. Next, let us find f of minus 2. If it is f of minus 2, it lies in the interval 1. Therefore, to find f of minus 2, we have to use the value of f of x as x minus 1. Therefore, f of minus 2 equals to minus 2 minus 1, which is minus 3. Therefore, we have to substitute in this. Therefore, f of 2 plus f of minus 2. F of 2 value is 4. F of minus 2 value is minus 3. Here we have plus. Plus into minus will become minus, which is equals to 1. So, in the next problem, f is a mapping varies from minus 5, 9 to r is defined as follows. F of x is given in 3 categories and we need to find these 4 subdivision. First, we will map f of x in the graph and then we will go on to that portion. We need only x axis 1, 2, 3, 4, 5, 6, 7, 8, 9. Minus 1, minus 2, minus 3, minus 4, minus 5. And the first option, it is given as x varies between minus 5 and 2, whereas minus 5 is included, 2 is not included. So, minus 5 is included and 2 is not included. Therefore, I am using open braces. For that interval, f of x value is 6x plus 1. And the second option is x varies between 2 and 6, 2 is included, 6 is not included, 2 is included, therefore we will use closed bracket, 6 is not included, therefore you will use open brackets. F of x is equals to 5x squared minus 1. And the third option is x varies between 6 and 9, 6 is also included, 9 is also included, both sides will use the closed brackets, whereas f of x value for this is 3x minus 4. So, this we will consider as first interval, second interval and in the third interval. Now, we will find out one by one. First option we are asked to find is f of minus 3 plus f of 2. F of minus 3 in the sense it falls in the first interval. Therefore, we have to use for finding f of 3 we have to use f of x value as 6x plus 1. F of minus 3 equals to, substitute here 6 into minus 3 plus 1. 6 into minus 3 is minus 18 plus 1, which is nothing but minus 17. F of minus 3 is minus 17. Next we will find f of 2. If it is x value is 2, we have to use the second interval. F of x is equals to 5x squared minus 1. So, f of 2 equals to 5 into 2 square minus 1, 5 into 4 minus 1, 5 4s are 20 minus 1, which is 19. Therefore, f of 2 equals to 19. Let us find the first option, which is nothing but f of minus 3 plus f of 2. F of minus 3 we got it as minus 17 and f of 2 we got it as 19 plus 19. Therefore, which is equals to 2. Second option is we have to find f of 7 minus f of 1. We will find one by one. To find f of 7, the value of 7 varies in the third interval. To find f of 7, we should use the third interval. Therefore, f of x is equals to 3x minus 4. We have to substitute the value of x as 7. Therefore, 3 into 7 minus 4, 21 minus 4, which will give us 17. F of 7 is equals to 17. Next, we will find f of 1. To find the value of 1, the x lies in the first interval. Therefore, we should use the f of x value as 6x plus 1. Substituting the value of x as 1, 6 into 1 plus 1, 6 plus 1, which is nothing but 7. So, f of 1 is equals to 7. We will substitute and simplify. Second option is f of 7 minus f of 1. F of 7 we got it as 17 and f of 1 we got it as 7. So, 17 minus 7, it is 10. Third option is we have to find 2 into f of 4 plus f of 8, we will find one by one. First we will find f of 4. To find f of 4, we have to use the value of f of x as f of x is equals to 5x squared minus 1. Substitute the value of x as 4. So, f of 4 is equals to 5 into 4 square minus 1. 5 into 4 square is 16 minus 1. 16 into 5 it is 80. 80 minus 1, 79. f of 4 is 79. Similarly, we will find f of 8 and simplify f of 8. To find f of 8, we should use the value of f of x in the third interval because 8 falls in the third interval. F of x is equals to 3x minus 4. F of 8 is equals to 3 into 8 minus 4. 24 minus 4, which is nothing but 20. F of 8 is equals to 20. The given question is 2 into f of 4 plus f of 8. So, 2 into f of 4 value we got it as 79 plus f of 8 we got as 20. So, 2 into 79, 18, 1 balance, 14, 15 plus 20, 158 plus 20 it is 178. Fourth option, 2 into f of minus 2 minus f of 6 divided by f of 4 plus f of minus 2. So, in this we need to find the value of f of minus 2, f of 6 and f of 4. f of 4 we already found, which is nothing but 79. We will find the remaining 2 and simplify. Next we will find f of minus 2. In order to get the value of f of minus 2, we should use the value of f of x in the first interval because minus 2 lies in the first interval. F of x is equals to 6x plus 1. F of minus 2 equals to 6 into minus 2 plus 1, 6 into minus 2 minus 12 plus 1, which is nothing but minus 11. So, f of minus 2 equals to minus 11. Next we will find f of 6. F of 6, to find the value 6 we need to use the third interval because 6 falls in the third interval. F of x is equals to 3x minus 4. F of 6 is equals to 3 into 6 minus 4, 3 into 6 it is 18 minus 4, 18 minus 4, 14. So, f of 6 is equals to 14. Let us substitute in the fourth subdivision. 2 into f of minus 2 value is minus 11 minus f of 6 value is 14, f of 4 value is 79 plus f of minus 2 value is minus 11. So, this will become minus 22 minus 14 divided by 79 minus 11. In the numerator, we have to add the terms, large number sign. So, it is 36 divided by 79, 11, 10, 1, 8, 90. In the numerator it is minus 36 and in the denominator we have to subtract 9 minus 1 8, 7 minus 1 6. So, it goes in the fourth table, 9 4s are 36 and this will be 17 times. Therefore, the answer is minus 9 by 17. So, the 11th problem is the distance S an object travels under the influence of gravity in time t seconds, which is given by S of t equals to 1 by 2 gt squared plus at plus b, where g is the acceleration due to gravity. A and b in this are constants. We need to verify this function S of t is 1 to 1 or not. For that, what we are going to do is, we are given with S of t is equals to 1 by 2 gt square plus at plus b. This we will consider it as equation 1. In t seconds, we will vary the values of t as 1, 2, 3 etc. it goes on. Okay, so if I take the value of t as 1, it will become S of 1 is equals to 1 by 2 g, 1 square is 1, so I will have it as it is, plus a into t, it is a plus b. Next I will put the value of t as 2. What it will become? 1 by 2 g t square. So, 2 square, 2 into a plus b. Simplifying this, 1 by 2 4 g plus 2a plus b. So, which will become 2g plus 2a plus 2b plus b. So what it is it? If I put 1 for the value of t, I got a different image. If I put 2 for the value of t, I got a different image. If I put 3, I will get another different image. Therefore, this is a one-to-one function. For every therefore, for every value, every different value of t, there comes different images. Therefore, S of t is one-to-one function. So, the last problem in exercise 1.4 is the function t which maps temperature in Celsius into temperature in Fahrenheit, that is T is mapped from C to F and defined by T of C equals to F, whereas F is given as 9/5 C plus 32 and we need to find all these subdivisions. And the first option it is given as T of 0. What is mean by T of 0? The value of C is 0, we will find. So, T of 0 is equals to F. F value is nothing but 9/5 C plus 32. We have to substitute the value of C as 0. So, 9/5 into 0 plus 32. Therefore, T of 0 is equals to 32 degree Fahrenheit. Second option is we need to find T of 28. T of 28 in the sense the value of C is 28. T of C is equals to F. So, instead of F we have to write 9/5 C plus 32 and the value of C we have to substitute it as 28. 9/5 into 28 plus 32. So, 9 into 8 72, 7 balance, 9 2s are 18, 18 plus 7 25 divided by 5 plus 32, 252 by 5 it will give us 50.4 plus 32, 50.4 plus 32 will give us 82.4 degree Fahrenheit. And the third option is T of minus 10. Similarly, on the right hand side we have to fill it with the F. 9/5 C plus 32. Instead of C we have to substitute minus 10. 9/5 into minus 10 plus 32. Cancelling this will give me 2 minus 18 plus 32. 32 minus 18 will give me 14 degree Fahrenheit. Fourth option, we need to find the value of C when T of C equals to 212. Okay, so T of C in the sense we have to write the value of F as it is given 9/5 C plus 32 which is equals to 312. We will simplify this, we can easily get the value of C. 9/5 C which is equals to 212 minus 32. 9/5 C which is equals to 212 minus 32 is 180. If I reciprocate, this will come to the other side. C equals to 180 into 5 by 9, 20. So, 100 degree Celsius. Last option is we have to find the temperature value when the Celsius value is equal to Fahrenheit value. We have T of C is equals to F. F is nothing but 9/5 C plus 32. What we told is when the Celsius value is equal to the Fahrenheit value, so both the values we will consider it as X. That is Celsius value as X, 9/5 and the Fahrenheit value also X plus 32. When they both are equal, what will be the temperature value? Let us solve this and find. So, X, this I will take it to the other side, it will become minus 9/5 X which is equals to 32. On the left hand side, if I take LCM, it will become 5X minus 9X divided by 5 which is equals to 32. Next step, this 5 will go to the other side. On the left hand side, 5X minus 9X will become minus 4X which is equals to 32 into 5. Minus 4X is equals to 10, 1 balance, 15, 16. So, X is equals to 160. This minus 4 I will bring it to the other side. So, 40. x is equals to minus 40 degree. The temperature value is minus 40 degree when the Celsius value is equal to Fahrenheit value.